Hi everyone, I'm Jessica and this is the STEM coding air pressure activity. In this activity, you're going to use your smartphone or tablet to take your own air pressure measurements as you climb up a few flights of stairs. Then you'll analyze your data to see exactly how air pressure changes with altitude. So if you didn't already know, most smartphones and tablets actually have air pressure sensors built into them, which is super cool. So for this experiment, we're going to use a free app called Arduino Science Journal, and that allows us to take measurements with those built-in sensors in our devices. So the first step in this activity is just to download the Arduino Science Journal app, and that's what the little app icon looks like. And then we'll take a look at how to use the app before we actually do the experiment. So I'll go ahead and open up my Arduino Science Journal app on my iPad here, and then we're going to want to create a new experiment by pressing the plus icon in the bottom corner, right there. And then to edit the experiment, you press the little pencil icon in the corner, and now you can name it whatever you want. If you want to change the name, I'll name it something like staircase, stairwell, air pressure, or whatever you want. And now you're going to press the sensors button at the bottom of the screen, right here. And you want to go to the air pressure sensor, which is the fourth one over. And you'll see at the top it's called a barometer. That's sort of the formal name for a device that measures air pressure. And what you're seeing right now, the number, it's giving you a real-time measurement from the air pressure sensor. So you might see it changing a little bit over time. But to take a singular measurement, you'll just press the snapshot button at the bottom here, and you see it says your note has been saved, so that means you successfully took the reading. And if you go back out to the main page of the experiment, you can see the reading now. And you can also add notes by pressing that little icon with the 6 dots right above it. And so you can add a description. You might want to keep track of your heights this way, but for now I'm writing test measurements. So that's basically how you use the Arduino Science Journal app. Now we can move on to step 3 in the activity. So usually we can assume that atmospheric pressure is approximately 100 kilopascals, abbreviated kPa, right up here, 100 kPa. So step 3 is asking you to take your actual measured value of atmospheric pressure that you took using Arduino Science Journal and compare that to the assumed 100 kilopascals to see how good of an approximation that really is. And specifically, we're going to be using this formula right here, which is a form of the percent error formula. So you see here, it's going to give us back a percent. And you would put your actual measured value of atmospheric pressure right in that blank. So I'm going to go ahead and switch over to my calculator screen so that you can see the actual calculation happening. And I'm going to use a free website called Desmos. And you can find this by just Googling Desmos, it's D-E-S-M-O-S, and clicking on the link to their scientific calculator. So I'm going to go ahead and type in the formula that you just saw in the activity. The first thing we need is an absolute value, and the way that you type that in this calculator is just ABS and then parentheses, and now whatever you type inside those parentheses, the calculator will take the absolute value of that. And then it was, I'll leave a blank for whatever your measured value was, minus the approximation, which was 100 kilopascals, kPa, divided by 100 kPa. And then the last step was to multiply by 100 to get it in percent form. So my measured value was 982.68 HPa. So you'll notice that those units are just slightly different than the 100 kilopascals or kPa. So we'll need to do a conversion before we do the calculation. So HPa stands for hectopascals, and hecto is another metric prefix just like kilo. So kilo means 1,000 and hecto means 100. So 1 kilopascal is 1,000 pascals, and 1 hectopascal is 100 pascals. So if I want to convert my measured value from hectopascals to kilopascals, all I need to do is move over the decimal point by 1 digit to the left. So if I do that, My converted number is 98.268, and I'll change that to kilopascals. So now you can see my measured value is actually pretty similar to 100 kilopascals, so maybe it'll be a pretty good approximation. And now, before we do the calculation, I have to delete these units so that the calculator doesn't get confused by the letters. And you'll see that the calculation is automatically done right here, and we get 1.7% error. So I would say 100 kilopascals is a pretty good approximation of atmospheric pressure. Now we can move on to step 4 right here, which is the last step that we have to do before actually doing the experiment. And all you need to do for this step is make a prediction about what will happen when you increase your height above the ground. Do you think the pressure will go up or down? And try to come up with an explanation for why. And it's totally okay to be wrong with your prediction, but just take a moment to pause this video and come up with what you think will happen. Now in step 5, we'll test our prediction by going to a stairwell and taking pressure and height measurements as you go up. And the only things you'll need to do this experiment is your device with the Arduino Science Journal app downloaded, a meter stick or ruler to take your height measurements, and a stairwell with a few flights of stairs.